Hello, we're going to talk about the stoic of molar ratios. We do not need a periodic table for this example. So if you hear molar ratios, you're converting from moles to moles, we will be able to do so without a periodic table. Let's begin. So I'm going to get my crossroads here. Boom, and I'll wait for the vertical line. Notice we have a balanced equation. We are also given a question, how many moles, and I like to make sure I write this down, or I highlight rather, how many moles of CO2, so we're trying to find CO2, are needed to make 8.7 moles of KCO3, K2CO3, okay? So what we can start with here is the given. We can write out our molecule of K2CO3 here. And actually, let's do this appropriately. Let's put out, we have 8.7 moles of K2CO3. Perfect. We don't need to put anything on the bottom left. You'll notice this is a common thing in Stoic. On this bottom right, we need to cancel out this moles of K2CO3, so we need to find the balanced equation molarity. I will highlight here where the molarity is in the K2CO3, and look at this. Our coefficient is 2 for our K2CO3. We also need to see what we are trying to find is CO2, and we notice that our coefficient for CO2, or our molarity for CO2, is 2. So this will be relatively easy. We can pretty much deduce what the answer is right now, but I think writing it out is important. So we have 2CO2, and that is in moles. So I should probably write that out, and maybe I'm making these mistakes on purpose so you can see that. We want to write out 2 moles of CO2, and below this, we want to have 2K2CO3. We can do the math here, and as you can see, if you know how to do these ratios, we wouldn't need to exactly do the math, but I'll write it out anyway so you can see. So we have 8.7. I'm going to blow this up for us. Let's make it 48. 8.7 times 2 divided by 2 equals, and what do you know it? It's 8.7. So the ratio is the same, so it's going to, the 2's are going to cancel each other out. We multiply the top, divide by the multiplied bottom, and this will be 8.7 moles of CO2. Nice and easy. Mole to mole ratios go quick. Let's do another one. We have 3V2O5, or rather our entire equation up top here. The question is, how many moles of aluminum oxide can you make if you start with 7.8 moles of vanadium oxide? Well, let's highlight what we are trying to find. We are trying to find moles of aluminum oxide, and what do you know? We start with 7.8 moles of V2O5, or vanadium oxide. So this is mole to mole ratio, so we are only dealing with mole to mole, but I think it's okay to be redundant because you're going to get questions for your tests that have multiple variations, moles to grams, and other areas. So let's write out what we have. 7.8 mole of V2, let's make that a little higher here, V2O5. Boom, nothing goes here. Let's look at our equation. V2O5, we have right here 3V2O5, and we have our aluminum oxide right here, 5 aluminum oxide. So we have 3 moles of V2O5, and we have 5 moles of aluminum oxide. We are trying to find aluminum oxide, so we're going to put that on top. 5 moles of Al2O3, and we have 3 moles of V2O5. We can do the math here. typing it out. We have 7.8 times 5 divided by 3. And I'm going to make this larger so we can all see it. Boom. 7.5 or 7.8 times 5 divided by 3. We get 13. Beautiful. 13 moles of aluminum oxide. And we're done. Next question. Our equation's up top. How many moles of O2, how many moles of O2, that's what we're trying to find, are needed to make 18.2 moles of H2O. So what we are given, the numbers we are given here, is 18.2 moles of H2O. Line here, nothing goes here. We are trying to find the moles of O2. Let's find it up top. We have a coefficient of 5, O2, and we find our H2O. We have a coefficient of 2. That's our molarity, is where that coefficient is. We are trying to find the O2, so we put it up top, 5 moles of O2, and we are trying to cancel out the moles of water, so we put it on the bottom. We can simply do the math now, okay? We have 18.2 times 5 divided by 2. I'll blow this up. Boom, boom, boom. Widen it out. 18.2 times 5 divided by 2, we get 45.5 moles of oxygen gas, O2. And we're done. Next question. Our equation's up top. Question is, how many moles of carbon monoxide, CO, are needed? So that is what we're trying to find. Are needed to make 15.5 moles. 15.5 moles of carbon dioxide. Kind of a fun one. What are we given? We are given 15.5 moles of CO2. Great. We need to find the moles of carbon monoxide. Okay, so we look at our equation up top and we see that there's a coefficient of 3 for the C and O, or the carbon monoxide, and we find that our CO2 has 3 as well. So this will be a nice and easy one. Because we have 3 CO2 and we have 3, and we make mistakes every once in a while, 3 CO and 3 CO2 on bottom. What you can do without even typing this in a calculator, since we already did one like this, the 3 cancels out the 3. The CO2 cancels out the CO2, and this should also have mole, and this should have mole. I'll kind of do a teacher's correction there. And this mole cancels out this mole. So what are we left with? We are left with 15.5 moles of carbon monoxide. 15.5 moles of CO. Easy. Nice and easy. Don't even need to do math for that when we have similar numerations or variables on top and bottom. Okay. How many moles of O2 are needed to make 6.5 moles of carbon dioxide? So now we have an oxygen reaction. Let's look at highlighting these things. We are trying to find the oxygen, the O2, and we are given 6.5 moles of CO2. Let's just highlight our molarity on top. We have CO2, so it looks like we have 2 moles of that. And let's highlight what we are trying to find. We're trying to find the O2, and we're going to have 3 moles there. Let's draw our line. Boom. What are we given? 6.5 moles of CO2. Get rid of that. What are we trying to find? Well, we're trying to find the 3 moles of O2. 3 moles of O2. And we need to eliminate the moles of CO2 top left. So we put the ratio on the bottom here, 2 CO2, or rather, writing this appropriately, 2 moles of CO2. And now we can do the math. So we can scroll down a little bit here, get our type ready to go. So we have 6.5, I'll get up here, 6.5 times 3 divided by 2 equals, make this nice and big, expand it out, equals 9.75. And of course, that is moles of O2. Why is it moles of O2? Because we can easily cancel out moles of CO2, because we divided those, okay? And we are left with moles of O2. Now, some teachers might look at this. We'll use the same problem for a variation here. They might say, what is the ratio between two things? And say it's a ratio between oxygen and carbon dioxide, or a ratio between O2 and CO2. It's quite simple. You might just be writing something, and I'll actually go a little above it right here. So we notice that the oxygen has a molar mass of 3, and the carbon dioxide has a molar mass of 2. So the ratio would be 3 to 2, if that was how they were explaining it. So you could get the problems in a varied, multiple different ways, but just know that if you write out the ratios, you can write them out as such if they're just asking for that ratio. And most likely there's going to be some guiding point if that's how you're going to write it. Otherwise, nice job. That was our last and fifth question. Hope you have a good day.